Ignition sequence start.
Good morning and welcome to Mission Control Houston and the International Space Station Flight Control Room. The men and women you see at the consoles this morning make up the Orbit 2 team of flight controllers, taking its turn watching over station systems and helping the crew members with their science and maintenance work in space. After making some history last week with a spacewalk by flight engineers Christina Cook and Jessica Meir, the Expedition 61 crew members turned their attention to the station's science mission this week, installing a new facility to support cell biology research.
Welcome to Space to Ground. I'm Isidro Reyna. This week, science hardware installation on station and more. NASA astronaut Andrew Morgan installed new life science hardware inside the station's Kibo laboratory called the Cell Biology Experiment Facility L. This is an upgraded Japanese device used in various life science experiments, such as cultivating cells and plants. Cell and molecular biology research cuts across all science disciplines in space biology, from understanding how single-celled organisms respond to the conditions of spaceflight, to how all of the various cells in a complex tissue or organ work together to help an organism as a whole acclimate to a foreign environment. By using both the newly installed facility with the original for the same experiment, astronauts can handle the processing of more samples on the station. NASA astronauts Christina Cook and Jessica Meir, who completed the first all-woman spacewalk on October 18th, participated in a press conference from orbit on October 21st. The duo answered questions about their 7-hour, 17-minute spacewalk, which included replacing a failed power controller and several other tasks in preparation for future spacewalks.
I've definitely drawn encouragement from mentors that I can see reflections of myself in throughout my life, and so recognizing that we may be offering that for future space explorers or explorers of any kind or anyone pursuing a dream was definitely a privilege and an honor.
For us, when we see that many times in our lives, it does make a difference if somebody can identify with somebody, something about them, some kind of shared experience with them, whether it's something similar to their background or experiences or what they look like or the fact that they have long curly brown hair, who knows? If sometimes that makes it easier to have an inspiration, have a connection and motivation for something great. So it really does mean a great deal for us to have this, to share this experience together, and hopefully it does inspire and educate those that will follow us.
This week's question comes from Alex. She wants to know if astronauts can listen to music when they work. The answer is yes. Astronauts can listen to music when they work. In fact, music has been interwoven throughout spaceflight history, from pre-launch songs to shuttle wake-up calls. Additionally, flight planners on Earth schedule time each day for astronauts to relax and have some fun. Some crew members bring their own musical instruments to the station to share their own tunes with fellow crew members, live in space. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
On the subject of spacewalks, many astronauts on the International Space Station get the opportunity to participate in spacewalks. These can be critically important to keep the station functioning properly, to support the science activities that go on inside and outside the vehicle. Think of the series of battery replacement spacewalks that started early this month, or the alpha magnetic spectrometer spacewalks that are targeted to start later this year. In this demonstration video, astronaut Ricky Arnold gives us a tour of the critical parts of the space suit that keep astronauts safe as they perform maintenance in the harsh environment surrounding the space station.
So we are standing in the Quest airlock, which is divided into two parts. We have the equipment lock and we have the crew lock. This equipment lock has a hatch right here that closes, and the crew lock has another hatch. The EMU, or the Extravehicular Mobility Unit, is our spacesuit, and it's divided roughly into two parts. We have the hard upper torso, which is almost like a turtle shell. It's a hard fiberglass shell, and then we also have the lower torso assembly. These spacesuits are our own little spacecraft, and they have everything you need to keep you alive out in space for 7 to 8 hours, maybe even longer, depending on how hard you're working. The only thing that they do not have, and they have radios, it has oxygen, it has carbon dioxide scrubbing, it has temperature control, it has everything you need except for one thing, a restroom. And so when we get ready for our EVA, the first thing we put on in the morning is a diaper. And that's our first layer. Then over the diaper, we put on a pair of long johns, and that's to keep our arms and legs from getting scraped up. It also provides a little bit of wicking in case you're getting really hot and sweaty. The next layer is our liquid cooling garment. And the LCVG has little tubes running through it, which allow water to circulate inside the LCVG to provide cooling when we're outside working really hard. So we've got the diaper, we got long johns, we got the LCVG, and then we're going to wear our spacesuit. 7 layers from the bladder on the inside, which maintains pressure, and that's a rubberized bladder, all the way out to the white layer on the outside. The crew member inside the spacesuit is also wearing this, what we call a Snoopy cap. It's a communications cap. We have a radio, so we can talk to not only to Houston, but we can talk to people on the space station and to each other. So we wear this communication cap inside the helmet. Also another key component of the EMU or a spacesuit is the helmet. You can see the helmet has a gold visor which protects us from the rays of the sun that we can bring down. It's pretty bright out there, and this gold visor helps reflect the rays of the sun so we can actually see and operate in daylight. At nighttime, we can raise this visor up, gives us a clearer view, and additionally we have helmet lights built into the helmet. On top of the helmet, we also have a television camera, so the ground is able to watch us while we work through these TV cameras. The work is really all done with hands, and so our gloves are really our most important piece of equipment in order for us to work outside. And one of the real challenges of a spacewalk is you have this heavy gloved hand, which is inflated. So it wants to stay like it's blown up like a balloon. But we walk by grabbing onto handrails and making our way along the ISS. So every time you move your hand, you're fighting against a balloon that wants to inflate. And then on top of that, all of our equipment is based on using your hands too. So after 6.5, 7 hours of kind of fighting against this glove, it's a really long day, and your hands are probably the thing that are most exhausted after 7 hours out on an EVA. Well, we're going out to work. You probably saw me move this mini workstation. The way we carry our tools is on a mini workstation, which is carried on the front. Every single tool we use is tethered to us. We do not want to accidentally create satellites. Our primary way of remaining attached to the ISS, if we're not using our hands, are these waist tethers. And you can see they just have a big hook. They go around a rail or anything else on the ISS and latch on, and it actually has a locking mechanism as well to hold us nice and tight. So we always want to have one of these attached if we're not holding on with our hands as well. The back of the EMU has our life support system. The life support system contains all the equipment we need, from a UHF radio down to the oxygen tanks that provide primary oxygen. One of the challenges inside this sealed environment, it's very easy to carry our own oxygen with us, but we generate a lot of carbon dioxide, particularly when we're out there working very hard. So to combat that, and to deal with that, we have these canisters called Medox canisters, which are just silver oxide. They are carried in the backpack along with a very large battery, which provides all the electricity for us. I don't have a battery here to show you today because we're in the process of charging them. We're about a month out from doing a spacewalk, and we've already started getting ready for that. So this Medox canister is able to remove about 7 to 8 hours of carbon dioxide that a human can generate inside the spacesuit. EVAs have allowed us to build and maintain the ISS, repair mission-critical hardware, investigate malfunctions, install new hardware, and the view, unbelievable. See you next time.
Flight engineer Drew Morgan will be one of the crew members on the AMS spacewalks. He's a guy who's had to know a lot about a lot of different subjects in order to graduate from West Point, then to become a doctor, then to become an astronaut, and he had to know some of that in Russian. We found that he can also think fast on his feet. He had fun with a rapid-fire Q&A on non-technical topics while he finished up preparations to launch to the International Space Station.
The clock has started. Roger.
What's your favorite movie?
Band of Brothers.
Your favorite food?
Anything spicy.
Favorite color?
Olive drab.
Are you a morning person or a night person?
Definitely a morning person. I'm not demonstrating that very well now, but yes, I am a morning person.
What's your favorite ice cream flavor?
Mint chocolate chip.
Is there one thing you have in your fridge all the time?
Milk.
What accomplishment are you most proud of?
My kids.
Who's the person who makes you laugh the most?
My wife.
What's your most memorable career moment?
Graduating from Ranger School and being promoted to major on the same day.
If you could have one superpower only, what would it be?
Time travel.
What's your favorite pizza topping?
Lots and lots of cheese.
Your favorite animal?
Armadillo.
Favorite dance move?
Air guitar.
Who inspires you?
My dad.
What would you like to be remembered for?
Being a good husband and father.
What advice would you give to your younger self?
Be a good team player.
What would be a good theme song for your life?
Live It Well by Switchfoot.
If you could spend one day on Mars, what would you do there for fun?
Take pictures.
What is a life goal you plan to achieve this year?
Come home safely from space.
Drew Morgan and his Expedition 61 crewmates are about a week away from welcoming a new shipment of supplies. The next Northrop Grumman Cygnus spacecraft will carry scientific research materials, including experiments ranging from human control of robotics in space to reprocessing materials for 3D printing. The astronauts and cosmonauts on the International Space Station serve as the laboratory assistants for researchers on Earth looking into a wide range of scientific concepts. And that includes some topics that we have to master in order to continue exploring beyond low Earth orbit, starting with the return of American astronauts to the Moon by 2024 as part of the Artemis program. For example, it'll be critical to understand how to interact with regolith, the fine particles of dust that cover the Moon's surface. And we're using the new Hermes facility to study how regolith particles move in microgravity over a long period of time.
If you look at asteroids or if you look at the Moon, you'll see this layer of regolith covering the surface. So it's this fine particles, fine dust that covers the entire surface. So what's happening is the solar system is very dynamic, and we have asteroids and meteoroids moving around and impacting different bodies. So the surface is getting bombarded all the time. So you have this fine layer of fragments on the surface. So why would we want to study it, right? And why would we want to study it on the space station? There's a lot of interest in one day sending astronauts to asteroids, for instance, and we have already sent a lot of robotic missions to asteroids and plan to send more. And so every time we visit these asteroids, we learn more and more. And there's very diverse bodies of asteroids. Every asteroid seems to be different. And so we would need to understand how to interact with the asteroid surface. So if you're going to anchor to the surface of the asteroid, for instance, you need to understand how to interact with the regolith. So asteroids are pretty small bodies, and so they have actually microgravity levels of gravity. And so this is actually what you find on the space station as well. There's 4 experiments, and each one is a tube. So it's a clear polycarbonate tube about the size of a Pringles can. And so inside this tube, we have the asteroid simulants. And so this is what we're actually studying. And so the main piece of data that we're getting is the movement of these particles. So we have a camera looking at each of these tubes. Over the course of about a year, that cassette 1 will be up there, we'll get this basically time-lapse imagery of the particles moving. And so we're looking at the long-term effects of microgravity and what's happening to the movement of the particles. Also, something that we have on asteroids is vacuum, right? So we want to expose our experiments to the vacuum of space. So we actually have our facility hooked up essentially to a port to space. We did cassette 1, but the idea is that Hermes will be open to other investigators. So cassette 2, cassette 3, cassette 7, these will be other researchers that will apply to use Hermes to do research on asteroid regolith and granular material investigations. And we think that ISS is a wonderful place to study asteroid regolith, to study lunar regolith in general. So we're excited about the opportunities that Hermes will bring for researchers in the future.
The Orion spacecraft is one of the major components of NASA's Artemis program, which will return humans to the moon in preparation for future missions to Mars. Astronaut Randy Bresnik explains the role of Orion in conjunction with the Space Launch System, Gateway Lunar Outpost, and a new lunar lander in carrying a new generation of astronauts to the surface of the moon and then safely home again to Earth.
Orion is the vehicle that's going to take and put the next man and the first woman on the moon by 2024. It's the vehicle that has to take us out of Earth's atmosphere, safely across the expanse of 250,000 miles to the moon, put us in a lunar orbit at the Gateway Space Station, and then sit there and wait while the astronauts go down to the lunar surface for the first time since 1972.
Artemis, this is Houston. Come in.
We read you, Houston. It's another beautiful day on the moon.
Then the astronauts are going to come back up to the Gateway, get on Orion, come back home, re-enter Earth's atmosphere, and Orion's going to be the ones going to be able to get us back safely on the ground. We have to come back from lunar return velocities, Mach 32, and dissipate all that energy. So that shape of the capsule that you see behind us is pretty much the same. We've got a heat shield underneath that allows us to re-enter the atmosphere. The big thing is when you get inside, it's 30% larger. Orion can carry 4 crew for 21 days, where Apollo was 3 crew for 14 days. Now, it's also taking a lot of advantage of technology developments, where now we've got glass cockpit. We've got digital displays to control all the systems and are able to give that to us in a digital form, pull up our electronic procedures and emergency function. It also has a lot of better computing power because, you know, while it's only 25 times faster than the space station computers, you know, that's space station's flying right now, but shuttle, it's 400 times faster than that. In comparison to Apollo, 4,000 times faster than the Apollo computers, because Apollo computers had less computing power than we have in our watches these days. A lot more safety redundancies. It also has composite materials, so we're able to make it lighter. We're also able to use 3D printing to make things that we couldn't make before. So it's really, really going to be, you know, next generation vehicle that allows us to have that return to the moon in 2024 and then keep going back every year after that and make that sustained presence on that South Pole that allow us to do all the things we need to be able to be ready to go from the moon to Mars shortly thereafter.
The International Space Station serves as a test bed for technologies that will be needed to support future flights of discovery beyond low Earth orbit. That includes systems that will be needed to complete technical tasks, as well as the systems that will be needed to make sure that the human explorers can survive the harsh conditions of deep space.
The sweet smell of life support. Presented by Science at NASA. When NASA astronaut Kjell Lindgren blasted off from Kazakhstan in July of 2015 for his first expedition aboard the International Space Station, he had some lofty expectations.
I was eager to see Earth from space, and I couldn't wait to float in microgravity.
And he confessed.
I kind of expected the International Space Station to smell like a locker room.
After all, what would you expect? It's an airtight spaceship continuously occupied 24/7, 365 days a year by as many as half a dozen hard-working and exercising astronauts. Lindgren was in for a surprise, however.
The air in the space station actually smelled great. The filters and the life support system do a great job cleaning the air. There were no issues at all.
First contact with the space station's clean air reminded Lindgren, a flight surgeon, of the impressive technology underlying the station's life support system.
On the International Space Station, we're testing technologies that will allow us to live comfortably during long journeys into the solar system. Our life support systems provide a properly pressurized atmosphere with the right amount of oxygen. It scrubs carbon dioxide from the air, it keeps the temperature in a comfortable range, and provides fresh water and light and everything that we need for good hygiene.
Hence, the sweet smell of the air.
While I was on the International Space Station, I felt a lot like a bridge builder, helping to pave humanity's path to Mars.
As mission planners look toward the red planet, we are definitely evolving from the lessons learned on ISS, says Molly Anderson, a principal technologist at NASA. We want to increase the level of recycling wastes beyond what we do on the station now. Our ISS water system can recycle about 93% of the wastewater back to clean water. The leftover fluid is referred to as brine, and we're flying a demonstration technology on station soon that will recover most of that water too. On the station, if all the systems are working, we can recycle a little less than 50% of the carbon dioxide back into oxygen. We're trying to get that number much higher, to at least 75%, and even up near 100%, she continues. While the space station still relies on cargo vessels to bring fresh supplies and equipment, improved life support systems can help reduce those needs, leaving more room for science and science equipment going to the station. Plus, Earth won't be able to help on missions that leave Earth orbit.
Hundreds of millions of miles from Earth, no one will be able to bring us fresh water or replace malfunctioning systems. We will be on our own, just us and the life support system.
That's why it is crucial for life support development to proceed aboard the station, an excellent testbed for future deep space flight. For more from the International Space Station, go to www.nasa.gov/station. For more news about the sweet smell of spaceships and the systems that support them, stay tuned to science.nasa.gov.
In order to support those future deep space journeys, scientists in NASA's Human Research Program have been trying to figure out what dangers a long-duration spaceflight like that poses for the human explorers, and how to protect the crews on those future missions. Some of that work is being done on orbit, but some is underway at the NASA Space Radiation Laboratory.
The NASA Space Radiation Laboratory is an outgrowth of Brookhaven National Laboratory's particle accelerator. It utilizes the heavy charged particle radiation beam from various components already existing at Brookhaven Lab to then deliver specific doses, ions, and energies of radiation to the actual NASA Space Radiation Lab itself, with the goal to determine the potential risks to human beings from exposure to radiation during space travel.
The bulk of the radiobiology data that we've collected from the NASA Space Radiation Research Laboratory has really helped us establish our space permissible exposure limits. NASA has a set of limits that helps protect the astronauts not only from the short-term effects of radiation, but also the long-term health effects. In order to establish what those limits should be, we have to understand how space radiation is different than terrestrial radiation. And the experiments at NSRL has helped us establish our permissible exposure limits in terms of protecting the crew from the risk of radiation carcinogenesis, and also setting non-cancer career limits to the brain for central nervous system effects, and also to the heart for cardiovascular disease.
The primary difference with trying to compare what type of radiation dose an astronaut would get on a mission to Mars versus what a person could expect in their day-to-day life over time is that time factor. Now, a mission to Mars, depending on when you go and how the planets are aligned and such, you're still looking at approximately a 2 to 3 year mission. And while that seems like a long time, it's very different than the amount of time that, say, a non-astronaut, just a regular person that has nothing to do with space travel gets over, say, a 70, 80-year lifespan from, say, some radon gas in the home, or from medical tests that are administered where you get a certain amount of dose from CT scans or PET scans and X-rays through the course of life. So you're delivering a certain amount of radiation dose in a more compressed period of time than you would to the person that has never been a space traveler and such. And that's one of the trickiest aspects to trying to determine radiation dose. The same amount of radiation dose delivered in a day is very different than that same dose delivered in 3 years, even though, well, it's the same dose. It's not that simple, and that has to be evaluated when you try to determine the potential risks of absorbing that kind of a dose.
If you'd like to get another look at that story or any of the other features we showed you today, you can do that on YouTube and on Facebook. There are the particular addresses. While you're there, be sure to look around, because there's lots of other cool stuff you will find about NASA and America's human spaceflight program. And if you're out on the internet anyway, check out Houston We Have a Podcast. That's where we talk to folks about their work in all aspects of space exploration. New episodes post every Friday, and today Gary Jordan explores the relationship between NASA and the U.S. Air Force in a conversation with the Air Force Vice Chief of Staff, General Stephen Wilson, and Air Force Colonel Nick Hague, newly returned to Earth from the International Space Station. Go to nasa.gov/podcasts for today's episode. It's where you'll find all of our previous episodes, too, and the full library of all of the NASA podcasts, all of which you could also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.